Hello everyone, welcome back to lesson number 18 where we're discussing related rates with trig. We did two examples in the previous video where we had to figure out what the trig function was. Well, now we're going to do something a little bit different where we actually are going to be given delta theta and we're going to have to figure something else out. So let's go ahead and read the question and draw ourselves a little picture and see what we can do with this question. So this is a beacon of a lighthouse 1 kilometer from a straight shore. All right, so let's go ahead and draw our shore, which probably should be a different color, but whatever. So we have water here, water. And so out here, so on this little island right here, we have ourselves a lighthouse. All right, so it doesn't have to be perfect. So this is going to be 1 kilometer, straight shore. So this is where our sand is, I should say. So again, the beacon of a lighthouse 1 kilometer from a straight shore revolves 5 times per minute. Okay, it revolves 5 times per minute and shines a spot of light onto the shore. So the light here is going to be shining onto the shore. It's going to be shining onto the shore. So just think about as it's going around and around and around, it's going to be highlighting this shore, right? So that's what that says. It revolves 5 times per minute and shines a spot of light onto the shore. How fast is the spot of light moving? Okay, so remember, it's shining its light on the shore when theta equals pi over 6. So we have a lot of stuff we got to figure out here. Well, the angle that's changing is actually right here. So this is b pi over 6. And so what we want to know is what delta x is. We got to figure this out. All right, so we want to know what delta x is. Actually, let's write that over here for us. Because again, it's asking us to talk about where it's shining light onto the shore. And the shore in this particular example is going to be our delta x. We are going to give that this value here, y, right? Y is going to be equal to 1. Y is equal to 1, right? And we also know that delta y with respect to t is going to be equal to 0, right? This isn't changing. The shore is not moving anywhere anytime soon, and the lighthouse isn't moving anywhere. So we know that delta y, delta t is going to be 0. So the first thing we're going to do here is just acknowledge, and we'll get back to this in a second, we're going to acknowledge which trig function we want to use. Well, we know delta x, which is and in this case, our opposite side, right? Our opposite side of a right triangle. And then we know the adjacent side. So again, we're going to use tangent. We're going to use tangent of x. Now be very careful here. Be careful with this, the way that we have this written out, the angle's up here. So tangent of theta is going to be opposite. So in this case, the opposite side is going to be x. And then the adjacent side in this case is going to end up being y. Okay, it's going to be y. Another thing that we can do before we even move on is the fact that y is constant, right? The change of y, it's still 1. So I can go ahead and substitute in what y is. So I've actually got a really simple problem. It's just the tangent of theta is going to be equal to x, okay? So we're moving along pretty quickly here with this problem. So let's implicitly differentiate. So the derivative of tangent of theta is going to be secant squared theta d theta dt. And then the derivative of x is simply going to be dx dt. Now, we have a little bit of issues with this right here because we know what pi over 6 is. We know theta. We know theta is pi over 6. But we don't know right this second what delta theta over dt is. All right? So we can go ahead and just write out that secant squared is going to be of pi over 6. So we can go ahead and write down the theta because the theta was given to us. Well, what is delta theta over dt? So you got to think about it like this. So this is going around, right? So think of a lighthouse. It's going around. 1. Now it goes 5 times. So it's 1, 2, 3, 4, 5. So that's what delta x is. What is that angle? What is that angle? So we can easily say that delta x with respect to time is going to be, well, we went around this 5 times, and what did our angle create? We created a 2 pi as we went around, right? One rotation is 2 pi. So if we're starting right here and we rotate one time, we've went 2 pi. So our theta has been 2 pi. Then I go and do 4 pi, and I do it 5 times. So whatever this number is, it's revolving, it's just going to be multiply it by 2 pi. Because again, that's what the change in theta has over the 5. And then this is also per minute. So per minute. So this is going to be what we're going to do here. So this right here is going to be radians per minute. Per minute. So our units are going to be in minutes. So this is simply going to be 10 pi. This is going to simply be 10 pi. So just think about these kind of questions. Well, what is theta doing over the course? Well, it told us 5 times. This had been 7 times. I would have multiplied by 7, be 14 pi. And so all we have to do now is just multiply these things together. Well, secant is the same thing as cosine, right? Secant is the same thing as cosine. Well, what is cosine? Well, the cosine is going to be the square root of 3 over 2, but let's flip it, right? Because secant is going to be so secant of pi over 6 is going to be, instead of square root of 3 over 2, it's going to be 2 over the square root of 3. And so if I square that, then I'm going to get 4 over 3. And I know you guys know that already, but I mean, I'm just always trying to think about ways to tell students how to know these things without the calculator and stuff like that. So, yeah. So 4/3 times 10 pi, and so we're going to get that the change in x with respect to time is going to be 40 pi over 3. And again, we're going to look at the problem and say that the units are kilometers per minute. Okay, kilometers per minute. And I hope that that makes sense for everyone, and we're good here. All right, and by the way, if you did not know how to find the secant of pi over 6 using the fact that this is cosine, you could use right triangles. You know, you could say, okay, well, this is pi over 6, and this is 1, and you could literally say, okay, well, I know that tangent of pi over 6 is going to be the opposite side, so x over the hypotenuse, and then do it that way and find out what the x value is, and then just do the other side from Pythagorean theorem. But you can find these other two sides if you have an angle and you have a side. That's the whole point of this part of the conversation, is that if you have an angle one side, you can find the other two sides by using simple trig. Okay, by simple trig. Okay, so I hope that makes sense. I'm going to do one more question that's very similar to this, and then that's going to be it. So let's go on into the next example. So I just read question number 7, and this is actually almost the exact same question as example number 3. So, I mean, it's the same thing. We have 1 kilometer, and from P, it's, you know, very similar to what we just did here. So the only difference is that we tell us what the 1 is. We tell us this is 1, this is 3. It says a lighthouse is located on a tiny island that's 3 kilometers north of point P, and again, it's on a straight shore. So this is the reason why I still am talking about this question, because this is a much nicer visual, right? A visual of this. The lighthouse lamp rotates at 4 revolutions per minute. So right there, now that we've seen a question like this, we know what delta theta is. We know that we can do 4 times 2 pi, and we know that that's going to be 8 pi radians per minute, right? So at least we have that part of the information that we already know. The other thing that I want to tell you guys in this problem is if I look at y and look at x, I know again that the change in y with respect to t is going to be equal to 0. So I know that it's going to be constant, right? And I'm asking you guys again, how fast is the illuminated spot on the shoreline? So again, on the shoreline tells us I need change in x. I need the change in x with respect to time here. I don't know what that is. So what is that? Moving along, when it's 1 kilometer from P, right? So they're actually giving us this distance of 1, which is great for us to know. And so we're again looking at change in y over change in x. So the opposite side over the adjacent side. So just like in the previous example, we're going to use tangent. So tangent of theta is going to be equal to the opposite side, which is x, over the adjacent side, which is going to be equal to y. And again, be careful with your sign. And you guys can make this y and x if you want to, but I always like the horizontal to be x and the vertical to be y. And just like before, we can plug in. We already know what y is, right? Y is actually equal to 3. We can plug in y here. So tangent of theta is going to be equal to x over 3, which again, our equation that we're going to use now is the tangent of theta is going to equal to 1/3 x. because again, delta y is constant. So we can go ahead and plug that all in. And so this is our problem. This is what we have to do. So just as a quick refresher, or let's just keep on going for this for a second, we implicitly differentiate this. So I'm going to go through this question very fast. We take the derivative tangent, which is secant squared, d theta dt is equal to 1/3 dx dt. Well, I want to find out what dx dt is. So I can go ahead and just multiply everything by 3 just to get rid of that. And just like before, guys, we've already found what d theta dt is. We know that that's going to be 8 pi. So we have this. We have this is 8 pi. It's equal to dx dt. So all I have to do now is worry about what secant squared is, right? Secant squared. Well, I know that secant is the reciprocal of cosine. So let's find out what cosine of theta is and just flip it, flip-flop it. So cosine is going to be the adjacent side, which is 3 all over the hypotenuse, right? Well, in this case here, we got to find what the hypotenuse is, and that's why they gave us this next side. We didn't get theta, we were given the other side, so that's why we need this by Pythagorean theorem. So 3 squared is 9, 9 plus 1 squared is 10, so this is going to be the square root of 10. So the cosine is going to be 3 over the square root of 10, which means that this is going to be the square root of 10 over 3 squared, right? 3 squared. So that's how you find that pretty easily. And so we're going to get, this is 3, this is going to be 10 over 9, this is going to be 8 pi. Is equal to dx dt, and when all is said and done, you can give me 2 answers for this problem. The first one for dx dt is equal to 80 pi over 3, right? 8, yes, because this is, yes, 10 over 3, yes, pi. Again, this is kilometers, right? We're looking at kilometers, and then this is per time. Where's our time here? Where's our time? Minute, right? Okay, that's me a second. So 80 pi over 3. And if you had a calculator, you could go ahead and just evaluate that, and that ends up being 83.776 kilometers per minute. Okay, so there are our 2 cases for our trig functions for related rates. I will probably do one more video, just extra practice if you guys need to see them, but that's the 2 type of trig function, related rate trig functions that you're going to need to know. So good luck, and I'll see you guys in the next video.